Welcome back to the deep dive. Today we're going to get into something pretty cool, Enset fibers.
Oh, yeah. Enset fibers.
You might not have heard about this one before.
Yeah.
But it all comes from this plant, Enset ventricosum.
Interesting name.
Yeah, and it's kind of like, if a banana had a cousin, but the fruit wasn't edible.
Oh, okay. So it's related to bananas.
It is, yeah, like in the same family.
Got it.
And that's why it gets these nicknames, false banana, or sometimes Abyssinian banana.
I've heard that. Yeah.
And so what's really interesting about this is it's not just some random plant out there.
Right.
In the Ethiopian highlands, this is a major food source.
Wow.
For something like 20 million people.
That's a lot of people relying on this one player.
Yeah, but here's the thing. It's given this whole other side to it.
Yeah.
Which is as a sustainable material.
Oh, interesting.
That could be used in all sorts of industries.
So you're telling me we got food and we got industry all wrapped up in this one plant.
Yeah, and that's what we're going to get into today. We've looked at a bunch of the scientific research to really understand this. How strong is this? How flexible is it? What's it made of?
All the good stuff.
All the good stuff, yeah. And, how's it been traditionally used? And then, where does it have the potential to be used in our modern world?
Mm-hmm.
And, of course, the sustainability side of things, too.
Of course. Got to think about that.
So our goal today is to really figure out, what is it that makes Enset fiber so special?
Yeah.
And what's the impact it might have for us? If you're the kind of person who likes to think about materials that are truly sustainable.
Yeah.
Not just, less bad, but actually good.
Right.
Or you're interested in plants where you can use pretty much every single part of it, then this one's for you.
I like where this is going.
Yeah. So yeah. I think it's interesting to think about, the fact that Enset ventricosum was only domesticated in Ethiopia.
Really?
Yeah. I mean, it's got wild relatives, in other places.
Uh-huh.
But the fact that it was actually domesticated there suggests that maybe there were some really specific fiber qualities.
Oh, interesting.
That were developed over time through that process.
Makes sense, yeah.
And there's actually hundreds of different types, or land races is what they call them.
Land race, okay.
Kind of think of it like different types of apples.
Oh, okay, varieties. Got it.
Yeah, which suggests that there's actually a lot of variety out there.
So a huge range of characteristics that we can tap into.
Yeah, exactly. So when we think about, the fiber itself, one of the most important things is tensile strength.
Right. How strong is this stuff?
Yeah, how much can you pull it before it breaks?
Yeah.
And what's interesting is that it really varies a lot depending on which part of the plant, how it's processed, all that kind of stuff. But the research shows anywhere from 352 to 900 megapascals.
That is quite a range.
It is a big range.
Yeah.
And so what does that tell us? What's the headline for you with that kind of range in tensile strength?
I mean, the first thing that jumps out is that the potential is there. You're talking about, upwards of 900 megapascals. That's a strong fiber.
Yeah.
But I think it also means that if we want to really use this on a larger scale, we need to figure out how to get consistent results. Standardization is going to be key.
Absolutely. So it sounds like, it's pretty strong, it's pretty long, it's pretty flexible too, right?
Exactly. And, you see that in how it's been used traditionally. They've been making ropes and mats out of this stuff for centuries.
I mean, that really proves its durability if it's lasted that long.
Oh, absolutely. And then you've got the low density, around 1.2 to 1.4 grams per cubic centimeter.
Which basically means it's lightweight.
Yeah, lightweight, which is a huge advantage if you're thinking about, building materials or even, things like car parts or aircraft components where weight really matters.
But like all things, there are some downsides too. I mean, one of the things that comes up is moisture absorption.
Right.
With all that cellulose, this stuff likes to soak up water.
It does, which can be a problem depending on how you're trying to use it.
Right, exactly. So how do you get around that?
Well, there are some treatments that can help, like using alkali can reduce the moisture absorption.
Okay.
And, we also see things like the elongation at break is around 2.5 to 3.2%.
And what does that mean?
So that just tells you how much it can stretch before it snaps.
Oh.
It's not super stretchy, but, for something like a rope where you need a little bit of give, it's fine.
Makes sense.
And then there's the crystallinity index, which is about 65%.
Okay, so let's get into the chemistry of it now. What is it about this fiber chemically that makes it so special?
All right, so the real star of the show here is the cellulose. It's got a high cellulose content, often between 50 and 70%,
Okay.
and that's where the strength and the stiffness come from. That's why it's good for making paper and even things like dissolving pulp.
Dissolving pulp.
Yeah, that's used to make certain kinds of textile fibers.
Okay.
And then you've got the hemicellulose, which is, part of what contributes to that water absorption we were talking about.
Okay, and I also noticed that the lignin content is pretty low, like around 5 to 10%. Why is that significant?
Yeah, that's actually a huge advantage when you're talking about turning it into paper pulp. You see, lignin is this really complex molecule that usually has to be removed, and with Enset, you don't have as much to deal with.
So it's easier to process.
Yeah, much easier. And of course, it's got some other components like ash, waxes, oils.
Like any plant does, right?
Exactly. And those might need to be removed depending on what you're trying to do with it. But what's really interesting to me is the holocellulose content.
Holocellulose?
Yeah, that's the cellulose and the hemicellulose together. And sometimes it's over 87%.
Wow, that's really high.
Yeah, so it's basically telling you this is a great source of those valuable plant-based materials.
So before we jump into like all the future potential of this,
Uh-huh.
I'm curious, how have people in Ethiopia traditionally used inset fibers?
Oh, well, this is where it gets really cool. I mean, they've been using it for so many things.
Yeah.
Strong ropes, for construction for livestock,
Yeah.
durable mats for their homes, sacks for storage. They even use it to reinforce mud walls and as decoration.
That's amazing.
It's really versatile.
So it's not just for like, structural stuff. It's everything.
Yeah, roofing, wrapping food, even feeding animals, packing things. It's clearly a really important part of their lives.
I mean, if they've been using it for all this time, that means something.
Exactly. And, a lot of these traditional uses are actually driven by women in these communities.
That's it going.
So it's not just about the material itself, it's about the people and the knowledge that's been passed down for generations.
Yeah, absolutely. So, all right, let's talk about the future. Where could we see Enset fibers making a splash?
Oh, the possibilities are really exciting. I mean,
Yeah.
you could see it in textiles. Its drought tolerance and its strength make it really promising for making yarn and fabric. And, with that high cellulose content, it's great for dissolving pulp, which is used to make things like viscose.
Yeah.
Then you've got construction. It's lightweight, it's biodegradable, it's renewable. You could imagine using it to make lighter car parts, which would improve fuel efficiency, maybe even safety.
That's a great application.
Yeah, and it could be used in more sustainable building materials, things like insulation or even wall
What
panels.
about packaging?
Packaging, absolutely.
Yeah.
That strong pulp can be used to make high-strength packaging papers, even specialty papers.
Ah.
And there's potential for biodegradable plastic films.
That would be huge.
Yeah, huge. And then, of course, paper and pulp itself. Enset is a fantastic source of long fibers. It's got that high holocellulose, low lignin.
Right.
So you get good pulp yields and you get strong paper. It's a really sustainable alternative to wood pulp.
Yeah, and it seems like, we can even use this for more high-tech applications, right?
Oh, absolutely. That high cellulose content makes it a really interesting candidate for bioplastics and even nanocellulose.
Nanocellulose, that's like the cutting edge of materials.
It is. It is. You're talking about, strengthening bioplastic films using nanofibers for things like sound absorption.
Seems like the applications are almost limitless.
Yeah, the potential is huge.
So the big question, the one everyone's thinking is Enset fiber truly a sustainable option?
Well, if you look at the big picture, it really does seem promising. I mean, it's biodegradable, it's renewable, it's a fast-growing plant that spreads easily. It's got a lower environmental impact than synthetic materials.
And helps with soil stabilization in Ethiopia, right?
Exactly. And, using what's essentially a byproduct of food production is a great example of a circular economy.
So it's like a win-win-win.
It really seems like it.
But, we always need to be careful and look at the whole picture.
Right. A full life cycle assessment is crucial.
You can't just assume that it's good. You have to really do the research.
Right. But the initial signs are very encouraging, especially when you consider how strong it is compared to other natural fibers.
Okay, so let's recap here. What have we learned about Enset fiber?
Okay, so we've got a fiber that's strong, it's flexible, it's lightweight, it's high in cellulose, it's sustainable, it's got this long history of use, and it's got exciting potential for use in all sorts of industries, from clothing to cars to construction.
Yeah, it's pretty amazing.
I mean, to me, what's really fascinating is how this plant that's so vital for feeding people can also have this incredible potential as a material. It's like this perfect example of how we can use nature to solve our problems.
Right. Absolutely. So, listeners, you've heard it here first. This seemingly simple plant holds the key to some really amazing possibilities for a more sustainable future. And it makes you wonder what other everyday resources are out there with similar hidden potential. As you go about your day, think about the implications for how we innovate and build a better world. Thanks for diving deep with us.